It's Sunday morning on a paradise island in Asia, home to 40 million people. Just offshore lies one of the largest geological faults on the planet. Scientists have been studying it for decades, hoping to understand its seismic behavior. Then, the biggest quake for 40 years rocks the region. Next, a horror no one had foreseen claims over 250,000 lives.
It was a surprise that it was so devastating. It caught us off guard.
It went from a perfect day in paradise to this horrific day in a matter of seconds.
Oh my God, look at the waves coming! Clear out, people! Clear out!
The experts are bewildered by a series of bizarre phenomena. Freak waves destroying entire communities.
The mega tsunami of 2004 is the greatest mystery we have yet to unravel.
Using cutting-edge scientific analysis, they shed new light on what really happened and reveal that tsunamis are more of a threat than the world ever realized. Disasters don't just happen. They're a chain of critical events. Unravel the clues and count down those final seconds from disaster. The Indian Ocean, the third largest in the world. On its eastern boundary lies a massive trench, formed at the edge of a vast fault line known as the Sunda Megathrust. Here, two of the world's giant tectonic plates collide. American geologist Kerry C. has been studying the fault for the last 10 years.
The plates are the biggest moving objects on the planet. The Indian plate is diving down beneath the Asian plate, and the overriding plate gets dragged down with it.
This collision zone is a breeding ground for earthquakes. And while the northern end of the fault has seen little major activity for at least 500 years, the southern end is a different story. Here, a big earthquake is thought to happen about once every 2 centuries.
The last one was in 1833, so almost 200 years ago. We were getting a little nervous that sometime in the next minute to next 30 years, that part of the megathrust might break again.
The megathrust is well known to geologists, but for most people who live, work and play around this vast body of water, the potential dangers were unknown. In the last days of 2004, all that would change forever. A jewel of the region is the Thai island of Koh Phi Phi. More than 150,000 tourists every year come to experience the dramatic scenery and glorious beaches. 25th of December 2004. The Moore family from California are having the vacation of a lifetime.
Hi, girls. Hi, Danielle.
It was our first time in Asia. Phi Phi Island was like no other place I'd ever been to before. Pure paradise.
Ken's been videoing his wife Gayleen and their daughters Kendra, aged 8, and Danielle, aged 6, as they enjoy their tropical Christmas.
Merry Christmas.
With my kids being 6 and 8. The best thing about Christmas was they had a big party. Our children were having a wonderful time.
Good job. And there's our hotel.
Thailand is just one of more than 20 countries that surround the Indian Ocean. 460 kilometers away is the politically troubled island of Sumatra. On its west coast lies the community of Lokna. Despite more than 2 decades of civil unrest in this northern part of the island, Lokna manages to maintain an easygoing normality. Its population of 15,000 crammed along a narrow strip of land between hills and the ocean. December 26th. It's 7:57 a.m. Ibu Nuleli hangs up the family washing while 3 of her children eat their breakfast inside the house, watching TV.
We live near the ocean, and this morning there is nothing unusual. No wind, clear blue sky.
The youngest of Ibu's children is 9-year-old Ichut. She's a bright and thoughtful girl and likes to help her mother with the chores. Ichut has a 16-year-old brother and a 17-year-old sister called Fitri. She has been blind since birth but has become an expert seamstress, to the delight of her mother.
Even though she is blind, she is very talented at sewing and embroidery. She makes her own designs.
Ibu has recently lost her husband, and her children are all she has left. 7:59. Deep beneath the ocean, the earth begins to shake. The tremors continue for more than 8 minutes. Ibu and her kids are terrified by the violence of the shaking.
We stay in front of the house just praying while sitting in front of our house.
At 8:15 a.m., a vast wave hurtles towards the Sumatra coastline. 8:16 a.m. The quake is over, and families all over the region try to take stock of what has happened. 28-year-old street trader Samsul Kamal surveys the damage. When he looks towards the ocean, what he sees baffles him. An expanse of exposed seabed. And he senses danger.
I know if the sea goes out that far, it will come back again.
Then, in the distance, Samsul spots a terrifying wall of water approaching fast. Within moments, Lochner is swamped by a maelstrom of turbulent water. A second wave thunders towards Ibu and her family. This one is much higher and towers over the trees.
We see the water. It's as high as a mountain.
Ibu tries desperately to hold on to Ichet, but the little girl is torn from her hands. On top of a nearby hill, Samsul watches as a third, even bigger wave approaches. Although he is 35 meters up, the mighty wave almost kills him.
The third wave went right over my head.
13 kilometers north lies Banda Aceh, the provincial capital and home to 300,000 people. 8:40 a.m. In the city center, 4 kilometers inland, an amateur cameraman films the aftermath of the quake. He captures this footage as seawater rolls slowly up the street. Suddenly, the flow accelerates. Within seconds, the water is moving faster than a man can run. As chaos unfolds in Sumatra, the tsunami continues its journey eastwards. On the holiday island of Koh Phi Phi, the Moore family prepare to leave their resort after a memorable visit.
Being that it was Christmas the night before, we were up late, and we just took a leisurely breakfast. And I remember thinking, oh, about another half an hour, we need to check out.
In their hotel room on the 3rd floor, Mum Gayleen and girls Kendra and Danielle are relaxing before finishing their packing.
My wife all of a sudden said, honey, look, grab your camera.
Ken sees that the pool area has been swamped.
At first, I just thought it was just a little tidal surge until I looked farther out into the bay and realized there was a 20-foot wave coming at the beach.
Oh my God, look at the wave coming! Clear out, people!
I surf, so I knew this wave had the potential to knock the hotel down.
Look out! Get in the room, get in the room.
We're trying to get the kids back away from the window in case the wave came through the window.
I hope no one was out.
Ken knows that they are in a dire situation.
I was beginning to lose it, and my wife said, no, we can't do that. We've got to be strong for the kids.
Okay, it's okay, girls.
While people fight for their lives in the eastern Indian Ocean, 2,000 kilometers to the west, in Sri Lanka, the Squire family from England have been spending Christmas on the halcyon beaches of Arugam Bay in the east of the island.
We knew it was one of the last family holidays that we'd probably be having as the children were getting bigger.
Louise and Phil have 3 children, 16-year-old Will, Laura, who's 18, and their eldest, Emma. Today is Emma's 20th birthday.
Happy birthday!
Louise and Philip arrange to meet Emma at the beachfront dining area. But first, Emma heads for the bathrooms to freshen up. As Louise waits for her daughter, she notices that water is seeping into the hut.
The floor of the restaurant begins to flood with water.
When she looks up, she sees a wide brown surge of water heading straight for her.
Something tells me this is incredibly life-threatening.
Louise immediately thinks of Emma, knowing she will be totally unaware of the looming threat. There are just seconds in which to act, seconds which could spell the difference between life and death. On the Asian island of Sri Lanka, holidaymaker Louise Squire sees the terrifying sight of an approaching tsunami. Her daughter Emma is unaware of the danger. Tons of water explode into the room. Within seconds, Emma is trapped and running out of time. Incredible currents begin to tear the resort to pieces, and Louise is swept away.
The next thing I remember, I'm just under a huge amount of water, and I'm thinking, this would be so easy to die in.
Louise drags herself to safety.
I remember thinking, where are my children? But knowing there was nothing I could do.
Over the next 2 hours, a series of waves swamp Arugam Bay. Eventually, the water recedes, revealing a terrible scene.
I see a completely devastated area.
Unable to find her family, Louise makes her way to the highest point on the island. Her last and only hope of finding them alive. But even here, there is no sign of her children or husband, and she begins to despair.
I start planning my own exit from the world.
But then she hears familiar voices.
Phil comes through the garden, followed by Emma, Laura, and Will. And it was just unbelievable. And we just hugged each other.
It was amazing. She just kept on repeating, I thought I'd lost you, I thought I'd lost you. We were all in tears. We couldn't believe our luck, how all 5 of us could have survived.
The tsunami continues on its devastating path, finally bringing chaos to the coast of Somalia in Africa. 5,000 kilometers from its first landfall. Even here, the waves killed 289. All across the Indian Ocean, incredible events have been captured on video. In Thailand, astonished holidaymakers film an exposed seabed. The water drained from the beach, followed minutes later by a vertical wall of water. 3,000 kilometers to the southwest, the Maldives, a low-lying island chain, are all but submerged. To the north in Sri Lanka, a shopkeeper films the plight of schoolgirls trapped in what was a bus station. Back on Koh Phi Phi, Ken Moore and his family face a shocking new reality as the flooding subsides.
The people in that bay were gone. We'd been out there snorkeling and swimming the day before, and this wave just came and picked everyone up and just washed them away. There was people with horrific injuries. I mean, broken arms and legs twisted and lacerations.
On Sumatra, the coastline is now unrecognizable. Ibu Nuleli desperately searches for her children.
After the water receded, I was confused and frightened. There were so many dead bodies. Not only people from this village, but people from other places too.
Ibu finds her blind daughter, Fitri, then her son. Together they look for the little 9-year-old, sifting through debris and corpses. But it's a race against time. With each passing minute, their chances of finding Ichut alive are dwindling.
We look for Ichut everywhere.
But after hours of fruitless searching, the awful truth is inescapable.
I couldn't find my little one. I haven't seen Ichut to this day.
Like so many youngsters, Ichut was not strong enough to survive the water. At least 1/3 of the tsunami's victims are children. This is the most devastating tsunami in recorded history. Entire communities are erased. The scale of the disaster shocks the world into action, and an international relief effort begins. But for many, it is too late. In total, more than 270,000 people are killed, but the true death toll will never be known. But what could have happened? What kind of tsunami can create super high waves, retreating oceans, and devastating debris flows? And most important of all, is there anything we can learn to prevent such a catastrophe from happening again? Fully understanding this complex disaster requires expertise from many different disciplines, and a team of world-class specialists come together to investigate. For earthquake expert Kerry C., this event raises conflicting emotions.
It's quite a schizophrenic experience. You have not only your scientific exhilaration, but you also are looking at something that's powerful enough to do a lot of damage to people.
Professor Kostas Sinolakis is head of the Tsunami Research Center in California. An investigator for 25 years, he's analyzed about 20 freak waves in 10 different countries.
Our work is very much like the FBI profiling a serial killer. We have to very, very carefully look at the clues. Then we can maybe point our finger and say, this is where the killer came from, and this is what he can do again.
Sinolakis is an expert in modeling tsunamis. He tries to predict what would happen to low-lying coastal communities such as his own in Southern California if they were hit by a wave of a certain size. And he advises where to locate public buildings, like hospitals, to avoid being swamped in an emergency. The Asian event perfectly illustrates the need for this kind of research.
Tsunamis, they're inevitable. It's just a question of time.
George Plafka is a pioneer of tsunami science and has been studying them since the 1960s. Even he is stunned by the images coming in from all around the Indian Ocean.
What was really surprising was the size of the tsunami and how destructive and deadly it was.
For all the experts, there are some particularly troubling aspects of the disaster. The first is the unprecedented size and savagery of the waves. Reports are coming in that in Banda Aceh, the destruction reaches as far as 4 kilometers inland. The second puzzle is the extraordinary range of the devastation. For a tsunami to cause chaos from Thailand to Africa, across 6,000 kilometers of ocean, about 1/7 of the Earth's circumference, the energy required is scarcely credible.
What happened was beyond any scenario we had ever seen or imagined ever before.
is the CBS Evening News.
As the disaster unfolds, the media is in no doubt as to what created this giant tsunami.
Earthquake followed by tidal waves.
An earthquake that rocked Sumatra just minutes before the killer waves arrived. The experts have to agree. But as early seismic data comes in, the size of the tremor is confusing. First reports indicate a quake measuring 8 on the Richter scale. This is strange.
Now, to put this in perspective, we see a magnitude 8 earthquake somewhere around the world, maybe once every 2 years.
A relatively common magnitude 8 quake is not powerful enough to produce the devastation seen. Then, as the monitoring stations revise and analyze their data, the estimate steadily increases. By the afternoon, a station in Colorado puts the quake at 8.5.
If that's the size, it would be the biggest earthquake in more than a decade.
By the end of the day, data from around the world confirms that the quake lasted an unprecedented 8 minutes and released so much energy that, strictly speaking, it is off the Richter scale.
By that point, we knew it was the biggest earthquake in 40 years.
The seismic data throws up another surprise. It seems that the origin of the quake was 30 kilometers below the surface, 150 kilometers off Sumatra. Paradoxically, in the northern section of the Sunda megathrust, the part long thought to be virtually dormant. Seismologists calculate that the megathrust probably ruptured along an astonishing 400 kilometers of the fault. A long, thin stretch of ocean floor seems to have risen in a matter of seconds. Sinolakis is all too aware of what could have happened next. As the seafloor moves up, it lifts with it a column of water, displacing billions of tons of liquid, causing a wall of water to move away on either side. To prove the scenario, Sinolakis feeds the data into the most powerful tool he has, specialized tsunami prediction software. But Sinolakis is perplexed by the outcome of the simulation. The software predicts that the biggest waves from a 400-kilometer rupture wouldn't even hit Sri Lanka. In reality, one of the most devastated coastlines.
It just doesn't make sense. The damage in Sri Lanka is a huge clue. For the tsunami to have hit Sri Lanka, the earthquake fault zone has to be way longer.
Sinolakis takes stock. He decides to revisit the seismic data. He knows from experience that seismic measurements recorded during a large quake do not always accurately reveal the true length of the earthquake zone. The sheer intensity of the main event can mask smaller movements further out along the fault. Often the best way to discover the truth is to look at the aftershocks that follow the first cataclysmic release of energy. These smaller tremors are caused as the fault settles down and can be pinpointed with greater accuracy. As Sinolakis scans the data, he notices a flurry of tectonic activity way to the north of the epicenter. It's a decisive moment. If this activity marked the northern limit of the rupture, it would stretch a staggering 1,600 kilometers, 4 times longer than had been thought. A rupture on this scale would be unprecedented, enough even to cause the killer tsunami. But the aftershock evidence is circumstantial. Sinolakis needs some real proof. If this fault has unzipped for such a huge distance, somewhere along its length, there should be evidence. Sinolakis knows that Kerry Sea is already on the ground in Indonesia and ready to help. Although much of the fault line lies beneath the water, it breaks the surface along its length in the form of a chain of volcanic islands. Sea hires a helicopter and flies north along these islands, looking for signs of recent seismic upheaval. As he approaches the island of Similu, he sees something that catches his eye. A ghostly ribbon runs along one side of the island, a reef that seems distinctly out of place.
I realized this island has come up out of the water and the entire reef is now exposed and dead.
C starts to measure how far the reef has been lifted from the water. By comparing the heights of the uplifted coral all around the island, he can discover the precise movement of the Earth's crust.
We first measured 50 centimeters of uplift. As we went further north, it became a meter. Further north, 1.5 meters.
The pattern of movement suggests that the western side of the island has been raised by 1.5 meters. It's incredible evidence. The tilted island marks the beginning of the tear in the Earth's crust.
We knew we had nailed down the south end of the source of the earthquake and the tsunami.
A similar survey of the other islands dotted along the megathrust could give C the evidence he needs to plot the true length of the rupture. But at this critical moment, the investigation receives a body blow. C hears that political turmoil on the islands to the north means he can go no further. If the length of the rupture remains a mystery, investigators will never get to the truth of why this quake shattered expectations to create the most notorious mega tsunami in history. Investigators are on the verge of discovering why the December tsunami was so deadly over such a wide area. Kerry C has located the start of the earthquake rupture, but he desperately needs to prove how far north it stretches.
We want to know more about that bulge on the seafloor. Was it 1,000 kilometers long? Or was it 1,600 kilometers long?
But with a helicopter survey ruled out, how will he proceed? Then, out of the blue, one of C's assistants has a brainwave. If the dramatic physical evidence Kerry has witnessed on one island can be seen from the air, then why not from space? He tracks down a satellite image of an island prior to the earthquake and juxtaposes it with an image taken afterwards. Comparing these images provides a breakthrough. The outline of the island has altered as a result of being tilted in the water. He also sees that the color of the surrounding ocean has been subtly transformed due to the change in water depth after the quake. C realizes that it's possible to work out the vertical movements of the seabed from these observations. This is the first time satellite images have ever been used in this way. The team systematically analyze images of other islands along the megathrust and calculate the amount of movement on the seabed. This audacious analysis reveals that the rupture is as long as suspected, an incredible 1,600 kilometers, the biggest ever recorded. A rupture of this length should be more than enough to account for the destruction witnessed as far away as Sri Lanka. Sinolakis returns to the wave simulation program and feeds in the precious new data. This time, the simulation delivers a tsunami that mimics almost exactly the distribution of real attacks. As this California-sized chunk of the Earth shifts by up to 20 meters, the waves it creates carry the complex imprint of the seabed.
As it moves up, the piece of seafloor of ocean bottom has its own peaks and valleys, and that creates the initial surface of the wave.
This unique pattern sets in motion a sequence of undulations that scientists call a wave train. In the deep ocean, each crest is no taller than 50 centimeters, but the wave train travels at incredible speed, up to 900 kilometers an hour, as fast as an airliner. Beneath the surface, a deadly column of water passes through the full depth of the ocean. As each wave enters shallow water, it slows down to a few tens of kilometers an hour. The back of the wave catches up with the front, and the wave rises. The tsunami takes shape. The wave train simulation correctly predicts where and when the real tsunami approached all the affected coastlines. Proof that the investigation has nailed the source of the tsunami. But the scientists now face an even bigger challenge in explaining the bizarre and terrifying events experienced by the victims as the tsunami made landfall. In Banda Aceh, a city has been reduced to rubble for something like 4 kilometers inland. There is nothing on record to match this. Understanding it is vitally important, not only for this part of Asia, but also for low-lying coastal regions all over the world.
Why is the wave so destructive so far inland? It's something unfathomable.
As soon as Sinolakis and his team arrive in Banda Aceh, they get straight to work, surveying the damage wrought on the city.
Tsunami investigations are forensic investigations. We try to reconstruct what has happened, and we pick up clues very much like detectives on a crime scene.
There are two key dimensions they are trying to measure. The first is the maximum height above sea level that the water reached, known as the run-up. The second is called inundation, the distance that the water pushes inland. The position of debris and watermarks reveal that the run-up varied from an astonishing 10 meters above normal sea level near the beach to around 3 meters in the center of town. The inundation is, as feared, truly amazing. The water swept an unprecedented 4 kilometers inland. Huge volumes of water have passed through the city, but Sinolakis knows that it's the speed of this water that does the damage.
1 cubic meter of water weighs 1 ton. So for every cubic meter of water that comes in, and we're talking about now hundreds of thousands of cubic meters, it's like having a car that's coming in at high speed and it's hitting you.
So, the first step in solving this riddle is to figure out water speeds across the city. If Sinolakis can establish the time the water took to travel between known locations, a simple calculation will give him the velocity. But getting this information is not easy. The first place to look would normally be eyewitness accounts of the event. But sadly, in this case, most of the witnesses are dead. And of those that have survived, many are too traumatized to help.
It's very difficult to get very, very precise information because a lot of people are in a complete state of shock. They've lost, some of them, all members of their families. So asking them to describe the tsunami is very difficult.
Sinolakis must think laterally. As he surveys the ravaged streets, he sees that sand and mud have been deposited right across the city, clogging every available nook and cranny. This is marine sediment, sand and mud picked up offshore and carried inland. Sinolakis has an idea. He knows that the depth of this sediment is directly related to the water's speed at that place.
If the tsunami comes in, very, very slow, we expect to see, more sediment close to shore. If it comes very, very fast, we expect to see thicker sediment layers further inland.
This dirt is his speedometer. The team carefully measure the layers of sediment deposited in key locations. Their painstaking analysis reveals an answer that beggars belief. The water flowed at up to 20 miles an hour across most of the city.
I would have expected the wave to penetrate inland, but I had never expected this kind of speeds, 20 miles per hour, 3 meters flow depth, 2 miles inland. This just didn't make sense.
He's at a loss to explain how such huge volumes of water can be traveling so fast, so far inland. But then comes another vital piece of evidence. Sinolakis hears about a video which shows the water arriving in the city center.
The piece of video is a turning point for us.
Captured on tape, the wave seems to defy physics. As it hits these streets 4 kilometers inland, instead of slowing down as would be expected, the wave accelerates. If he weren't witnessing it with his own eyes, he'd consider this impossible. Sinolakis scans the video for clues. Rewinding the action, he focuses on the minor flooding that preceded the main torrent.
The first wave was very, very slow. And you could walk away from it.
But then, he makes an observation that will radically transform the science of tsunamis. This shallow layer of water is preparing the way for a deadly event. The first wave provides a low-friction carpet for the following wave.
The second wave is moving on this very, very thin layer of the first wave. So it's able to propagate much faster.
Lubricated by the wet surface, the second wave is able to power through the streets without slowing down.
Suddenly the second wave accelerates and goes at the speed of 30 to 40 kilometers per hour.
It's an extraordinary, shocking sight. The shattered debris becomes part of the flow.
It's like being thrown in a concrete mixer with nails and hammers and screwdrivers. This is unfortunately how people die. They had no chance.
It's a grim but valuable lesson. To survive a tsunami in a town, neither outrunning the water nor hiding in a back street will help. The only escape is to get to a solid structure and go up, as high as possible.
The difference of life and death in Aceh, in some cases it was a difference of a few inches.
But just as Sinolakis starts to believe he's solved the mystery, he hears reports of implausibly large waves just 13 kilometers to the south, in Lochna.
I start hearing things that are very puzzling. The run-up they measure is huge, in excess of 30 meters.
30 meters is 3 times more than the maximum water depth in Banda Aceh, and he has no explanation. Sinolakis asks veteran tsunami scientist George Plafka to investigate.
Based on all of my experience, the wave for an earthquake of that magnitude should have been about a 12-meter high wave, but certainly not anything near 30 meters.
Plafka meets with Samsul Kamal, the local street trader who climbed a hill to escape the water. He describes 3 enormous cobra-like surfing waves, each one larger than the last.
The third wave went right over my head.
Plafka's team measure the run-up at Samsul's hilltop refuge and discover that the water reached an astonishing 35 meters above sea level, higher than an 8-story building.
That's by far the largest tsunami associated with any earthquake in history.
But there's more to Samsul's story. He's sure that the waves arrived about 20 minutes after the quake began. Plafka is stunned. He knows that waves from the megathrust, 200 kilometers offshore, would take at least half an hour to reach Lochna. For a tsunami to arrive within 20 minutes means that a different mechanism must have been at work. Something capable of causing massive waves to arrive far earlier than was believed possible. It's a huge setback.
This is nothing less than throwing us back to the drawing board.
This anomaly strikes right at the heart of the investigation, but resolving it will rewrite the rules of tsunami prediction and reveal how vulnerable hundreds of millions of people living near an offshore fault really are. Investigator George Plafka has discovered that monstrous waves arrived on the west coast of Sumatra too early to have come from the source of the main tsunami. And the investigation is in crisis. Plafka is under pressure to solve this paradox and decides to go back to basics. He knows that the waves arrived about 20 minutes after the quake began, and he knows how fast the waves could travel through the waters immediately offshore. So, working backwards, he calculates how far away the waves must have started their journey.
It turns out that the wave could have traveled a maximum of about 100 kilometers.
George consults a detailed geological map of the seafloor. There, 110 kilometers offshore, he sees strange features that catch his attention. Distinctive folds in the seabed. Could this be the answer? He knows that features called splay faults are often found near large earthquake zones. They are where the enormous forces find a weakness in the highly stressed crust, and fractures break to the surface many miles from the main fault itself. Splay faults can cause a long, narrow section of the sea floor to pop up in a matter of seconds. And this can produce a distinctive short burst of high waves, just like those that flattened Lochner. It's an attractive theory. And when a computer simulation incorporates Plafka's splay fault, the results are nothing short of spectacular.
Lo and behold, it more or less doubled the height of the waves at Lochner, and it shortened the time, of course, of arrival.
With a pop-up fault located close to shore, the simulated waves closely match the awesome descriptions of eyewitnesses. A Japanese seismic team gives the theory extra credibility when it detects aftershocks in exactly the area that Plafka has identified. Although it will require further research to prove, Plafka's explanation is a breakthrough. But there is one final question raised by this catastrophe that's perhaps the most important of all. Can anything be done to alert people to the danger of an approaching tsunami? Increasingly sophisticated warning systems are in place across the world, capable of detecting a tsunami as it passes through the open ocean. But even such high-tech systems cannot always be the perfect solution. For 60% of the victims of the Asian tsunami, no alert would have helped. The coast of Sumatra is too close to the source of the waves for a warning to have had any effect. There was no time to react. But in the aftermath of the disaster, the investigators are tantalized by the possibility of an unmistakable natural warning sign. In many places, the ocean receded before the waves hit, and popular wisdom now says that an exposed seabed is the universal alert that everyone craves. But Sinolakis is not happy with this simple rule. In fact, it may be a potentially lethal myth. He has long held a theory about what could be happening to create these strange recessions. As the fault ruptures, the easternmost section subsides, pulling a trough of water down with it, a negative wave. As this approaches the shore, it draws the water away before the first crest arrives.
On this side, where the seafloor subsides, what you see first is the shoreline retreating.
All the waves traveling east lead with this trough, but to the west, the story is very different.
On the other side, where you have the seafloor uplifting, what you see moving west is a leading elevation wave, or, the crest comes first.
Up until now, this has been just a theory. But Sinolakis obtains evidence that confirms his hunch. Locations to the west saw no recessions, just a roaring wall of water slamming into the shore. It's an important finding that, disturbingly, runs counter to people's assumptions. Sadly, there is no single foolproof indicator of an imminent tsunami. Finally, we can now reveal the critical chain of events that plunged the people of the Indian Ocean into a primordial fight for survival. Prior to 2004, scientists identify the southern section of a fault line off Sumatra as a critical risk for a giant earthquake. Then, on December the 26th, 1 minute from disaster, a section of fault further north than expected begins to break apart, and a weakness in the crust creates a shortcut to the surface. 8 a.m. A narrow section of ocean floor, about 100 kilometers long, pops up by more than 10 meters. 3 giant waves approach shore. Meanwhile, the tectonic plates themselves spring apart, displacing billions of tons of water. The energy of the earthquake is transferred into the shifting water columns, equivalent to more than 30,000 Hiroshima bombs. On land, initial flooding creates a low friction surface for later waves to glide over, creating huge water velocities that turn debris into deadly projectiles. The human cost is incalculable. Almost everything that Ibu Nuleli owned has gone. Her only photograph is a portrait of her lost daughter, Ichut. The unexpected location of the December quake means that every undersea fault must now be considered a tsunami threat. Kostas Sinolakis is painfully aware that his home on the seismically active west coast is inherently vulnerable. But his experience of the Asian tsunami has only increased his resolve to plan for that day.
Whenever we see a tsunami on the west coast of the United States, we're going to be prepared, and hopefully we're not going to have any human victims.
Oh my God, look at the waves coming, clear out!
For Ken Moore, his experience in Thailand has been a wake-up call.
I don't take life for granted anymore. I realize that it can be all over in a second. And boy, I kiss my kids every day before I go to work.